In this short video, we'll use PICWave to study the gain of a semiconductor optical amplifier. So in this simple model we have in front of us, we have the gain section in the middle here, and we have both a current drive at a constant value of 200 milliamps and an optical signal at a constant value of 0.1 milliwatts. And then we have two monitors at the left side and the right side. So if we do a calculation using the TD-TW calculator, PICWave will calculate the time response over this 50 nanoseconds. And then we can look at the gain achieved with this semiconductor optical amplifier. Once the calculation is finished, we can click the Inspect button. And then straight away on the Instruments tab, in other words, the monitors, let's first double check the optical signal. This is the signal that came in, a flat 0.1 milliwatts, and the optical signal out is much larger than 0.1 milliwatts, approximately in the steady state region, approximately around 2.34, so a gain factor of around 23. Okay, let's do a second simulation. In this case, I'll open up a slightly different model. The model is exactly the same, but the optical signal is actually split into three sections. We have 1 nanometer of 0, 50 nanometers where we go from 0 to 1 milliwatts, and 50 nanometers where we go from 1 to 10 milliwatts. And if we run the calculator again, we can now plot essentially the output power as a function of input power to understand the gain efficiency. So this elbow here is the change from the two input signals from 0 to 1. And now we're going quickly from 1 to 10 over the next 50 nanoseconds. Now when we click the Inspect button, what I'm going to do, instead of have a graph where the x-axis is time, I'm going to put the input power on the x-axis. So I'm going to select it here and click this button. And now I'm going to plot the output power. So what we have here is on the x-axis is the input signal, and on the y-axis is the output signal, showing how the gain efficiency trails off as we go to higher power values.